Oops, that's the wrong slideshow. That's not what I want. This is the one I want.
I found this in our notebook. Lesson 6.6.
All right, turn it in when we turn the stuff for another homework. All right, quiet please, I can't hear. Hands for lunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Only 12 today.
Today is barbecue sandwich.
Oh.
That's
What? Okay, be there in just a second.
Oh, no.
I do not have my homework, but I shall do 2 things. You see how long I talk?
All right, you've now lost 30 seconds of your lunch, right? You will be behind all the other people going to get their lunch for 30 seconds. Hey, we're not playing this anymore, right? If you want to look at my videos and stuff, you know, I reviewed a couple of them last night. It's me saying, all right, guys, let's go. All right, guys, be quiet. All right, please, everyone is ignoring me. You're going to ignore me. There's going to be, you're going to pay for it. So you owe me 30 seconds. 30 seconds at the end of the class, 30 seconds during your lunch, meaning like, who's your 5th period? I will tell Mr. Calinello he holds you 30 seconds when the bell rings.
Oh, well, that you'd have to tell our history teacher because it's right after her.
Right, so Mr. Calinella is your 4th period? Who's your 4th period? So Ace is right. All right, so let's just cooperate and graduate, as we like to say. Meaning, like, I'm not a stickler for that much, but come on. I should only have to tell you one time. Any questions on the homework? Caden, what was your question? Numbers.
14 and 16.
Let's look at number 14. Instructions say make a unit rate. In general terms, how do we make a unit rate?
You, like...
In general terms.
Like, don't you divide the bottom number by the top number?
Other way around. So we're going to divide top and bottom by the bottom number. So we turn the denominator into 1, and we have a unit rate. The only thing we got to be careful of is if you can make like units, you must make like units. So some of these you can, some of these you can't. On number 14, centimeters to grams, right? One is a measurement of, and one is a measurement of mass, right? So we can't convert that. So it's 36 over 48. So 36 over 48. So what do I have to do? Just need to divide top and bottom by 48. So you're going to get a really, well, you're not going to get a pleasing answer here because you're going to get a decimal number. So 36, whatever 36 divided by 48 is, well, let's see, 36 divided by 48. 48 is close to 50. 50 would go into 367 times. I'm just saying if that was a 50, there's a 360. So 50 goes into 350 about 7 times. It's a guess. We'll see if it works. 7 times 8 is 56. Carry your 5. 7 times 4 is 28 plus 5, 33. It was a good guess. We do the math. That's a 4. That's a 5, that's a 2. So we get 240, 48 to 240. I don't know, it's about a fifth, it's about 50. 50 goes into 240. 5 or 4 times, probably 4. 5 would probably be too much. So we'll guess 4. Anyway, long story short, that's the math you got to do. Right? It's going to be an ugly, ugly answer. The book actually writes it as a fraction. So instead of doing the long division right here, ends up being close to 75%. The book actually just simply says, well, you said divide 36 by 48, just reduce that fraction right there, and it's 3/4. Okay. Turns out that we did the subtraction here, we find out we're off by 1. Look it up. 5 times 8 is 40. Carry forward, 5 times 4 is 20, plus 4 is 240. So it's 0.75, 3/4. Yeah. Number 6, the instructions state, write a ratio in lowest terms. Once again, we need to see if we can convert. If we can convert, we convert. If not, we don't. Number 6 says centimeters to meters. We got centimeters and we got meters. What do you want to do? Centimeters to meters or meters to centimeters? We do small to large. We can. We're going to get a decimal. It's okay. It's fine. I'm just saying I would almost always, you get a feel for it. Like if there's only 1 centimeters, right, you're going to get a very small number. If there's 1,000 centimeters, maybe it does make sense to convert to centimeter, but there's no rule for it. There's whatever floats your boat. Meaning like whichever one you want to do is fine. Me, I'm always going to do large to small because I know that way I won't ever get a decimal. So let's see, in meters, we have 3 meters. So I'm going to convert 3 meters to centimeters, and then I got centimeters compared to centimeters. So King Henry died by drinking chocolate milk. Meters to centimeter. You really want to go to this M, that's your milli. Meters is the B, and I'm going from meters to centimeters. So how many letters? 2 to the right. So if I move that 2 to the right, that turns into 30 would be 1. It turns into 300. There are 300 centimeters in 1 meter. All right, my centimeters in this case was 25, and it says do, this is your first, this is your second. So my ratio would be over 300. Remember, now they're both comparing centimeters. When you reduce that fraction, whatever that reduced to, that's your answer. What is it? 1 to 12. All right, anyone else? Yes?
22.
So 22, we're talking about prime numbers. What's a prime number? Is only divisible by in itself. There you go. So in 22, it says the prime numbers between 10 and 25. All right, between, that doesn't include 10, that doesn't include 25. Okay, is 11 prime? Is 12 prime? Is 13 prime? It was 14 prime. By the way, what can I immediately exclude? All even numbers. They can't be other than 2. 2 is the only even prime number. So I'm not going to say 16, 18, whatever. I'm only going to think of odd numbers. Is 15 prime? Is 17 prime? Is 19 prime? What goes into 19? 1, right? Is 21 prime? Is 23 prime? There are all your prime numbers, 11, 13, 17, 19, 23, between 10 and 25. Part A says to the whole numbers between 10 and 20. Now it says between, so it's not including 10 and 25. At least that's my interpretation. I'll check here if my answer matches the book answer. My interpretation, they say between, that doesn't include. So let's see, we got to count all the numbers between 10 and 25, not to include 10 and 25, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I'm getting 15. So there are 15 whole numbers between 10 and 25. And we had 1, 2, 3, 4, 5. So I get 5 over 25, and that reduces to. And the book says the answer is 5 over 14. So guess what they did? Since my number doesn't match their number, guess what they did?
They included.
They included. So add 2 to this. And there's your answer.
Yeah.
All right. Yeah, I would absolutely not include 10 and 25. The number says between. All right, anyone else? Yes. Number 8. You got S and MIN. What does that mean? S and MIN. Take a guess. Okay. MIN, minutes. So therefore S would be seconds. So do you want to convert seconds to minutes or minutes to seconds? How many seconds in a minute? So I take whatever they give me for minutes and I multiply it by 60. So on this one, I've lost my place. What number was that? 8. We're given 5 minutes. 5 times 6 is, or 5 times 60 is 300. So you got 300 seconds, and we're originally given 48 seconds, so 48 over 300, whatever that reduces to. All right. Here we go. Okay. 2 is 1/2, 1/3, 3 over 2. That was ABC. Number 4, 2/3, 2/5, 5/3. Number 6, Pierce already said the answer was 1 over 12. Number 8, 4 over 25. Number 10 is 4 over 1. There are 16 ounces in 1 pound. Number 12. Now, some of these are going to write as fractions. Some it's like they can't make up their mind. I'll accept either decimal or fractions. Number 12 is a decimal is 31.5. Number 14. Now they want to use a fraction, so they say 3/4. You put 0.75, same answer. Number 16. Now they go back to a fraction. 62.5. 62.5. Number 18, and now they go back to a decimal, 8.2. Number 20, A is 5 over 2, B is 5 over 7, C is 7 over 1. Number 22, we just said 5 over 14, 5 over 9, and 14 over 9, ABC. Any questions? Nothing? All right. Up, pass out. Once again, e-learners in periods 1 and 4, you must take your finals on the day it is assigned to you. For my math test for period 1 is on Tuesday, and for period 4, it is also on Tuesday. So on Tuesday, you must take your math test. I think I've said this many times. Monday is a whole day. We will take one final. Period 1, that is English. Period 4, that is science. That will occur for the in-class learners. That will occur during period 7, period 8. It will not be a student advisement. We will all roll that into period 7. You'll take your final, go home, come back the next morning, go to student advisement for 30 minutes, go take your first exam, go back to student advisement for 30 minutes, eat a snack. I would highly encourage you to bring a snack. Your butt's going to be in a seat taking a test all day long, or half a day, because it's half a day. After that 30 minutes, you go back to your next class. You take your second final today. You go home. Rinse and repeat Tuesday through Thursday. If all your tests are complete by Thursday, you go home. We see you next year. If you miss a test, you will come on Friday to make it up. Please communicate with your teachers if you're going to miss something. That way, I mean, some people already know, hey, I'm going to miss this. I have an appointment or something like that. That's fine. Communicate. You do nothing. You're like, well, if I do nothing, it'll be okay. I just want to take the test. We're going to put a 0 in the grade book. It's going to greatly affect your grade. Do not miss your finals. Abby. Okay, so I'll just say this. We said officially, right, your makeup day is Friday. If you have any time during that, hey, there's the PE, right, where you don't have a final, and you talk to your teachers or whatever, we have the flexibility of me saying, well, just show up to my class. I'll give you the final when you have your PE, and that way you don't have to come on Friday. Which day? Absolutely, but if you don't show up, You getting a 0, right? Or you show up on Friday. That's your choice. Yeah.
So my little brother, so for next
He only gets Friday as a half day.
wait, so I don't have to go to school on Friday, but
He does.
and then
And then you're getting out Tuesday through Thursday at 12. He's not. That make sense? Okay. All right. Homework. This will be homework / classwork. You're supposed to get this done in class either now or during student advisement. Now or student advisement. You guys have the music thing tonight?
no, we did it already.
You did it already. Never mind for you guys. Somebody has it tonight.
I think it's
9th and 10th or something? I don't know.
I think that's recording.
Oh, it's being posted.
Yeah, because we can't have audience.
Right. All right, here we go. We've done a lot of hard work this quarter or this chapter. It finishes up on a kind of like shifts gears, or it goes turns right, turns up, whatever metaphor you want to make. We do something seemingly different. Okay. The only thing is that we're still dealing with fractions. Okay. So this is just an application of fractions. Many of you already know it. Some of you don't know it. It's actually pretty easy. Here we go. Something called proportions. All right. Recall this. We made equivalent fractions last chapter, right? I gave you 2 fractions, and I asked you to make another fraction besides 1/2. You multiplied 1 and 2 by any number that you liked, and you made another fraction. In other words, I multiplied by 2. The pizza analogy here showing you that both things interpret to 1/2 of a pizza. I can do it again. I can multiply 1/2 times 3, top and bottom. We get 3/6. Once again, the pizza analogy and the fact that all 3 fractions are equivalent to each other. They describe the same part of the whole. Also recall this. We made ratios. Last couple classes we've been making ratios. Those are just 2 numbers compared by using division. That's a fraction. Hey, here's 2 fractions, same or different. Turns out, what would happen if I write 2 fractions that they're the same, that since they're the same, I could write between them. If 2 fractions are the same, what can I put between them? I can put an equal sign. When you do this process, 2 fractions that are literally equal to each other, you will form mathematically what we call a, write that down please, box 1. Hey, a proportion is literally an equation, hey, there's an equal sign, that states that 2 ratios are equal to each other. In other words, it says 2 fractions are equal to each other. That's what we call a proportion. Proportion is an equation, there's the equal sign. It states that 2 ratios are equal. They are the same. Everybody okay? 2 fractions that are equal to each other. It says ratios. All right. Remember, we have colon form. We have for ratios. So I could say 1 is to 2 as 3 is to 7. Or 3 is to 7. 3 is to 6. All right, proportions. Hey, there's a proportion. Why do I know it's a proportion? 2 fractions equal to each other. Hey, there's another proportion. 2 fractions that are equal to each other. Here's another proportion. 2 fractions that are equal to each other. Here's a 4th one. Boy, there's 4 examples of fractions that are equal to each other. Okay, turns out, once again, that something magical happens when you have proportions. Check this out. The number 1 thing that confuses 7th and 8th graders is what I'm about to show you. Okay. This is called cross. We've heard this word before, cross. We've heard about cross reduction. I want you to remember, cross reduction applies when you have 2 fractions that are being multiplied together. Cross reduction applies when 2 fractions are being multiplied together. Are these fractions being multiplied together? So this is not cross reduction. I said this is confusing 7th and 8th graders. The words sound the same. Someone's already said it. What I'm about to show you is something called cross multiplication. Cross multiplication only applies to proportions. Cross reduction, cross multiplication. Okay? That's why obviously 7th and 8th graders confuse it, because it sounds almost similar. You will use cross multiplication when you see an equal sign. You will do cross reduction when you see a multiplication sign. Okay, I see an equal sign. We can do this thing called cross multiplication. What is it? Cross multiplication says this. A cross multiplication, cross multiply, here's multiplication symbol. Can you see the X that's formed?
Yeah.
We apply this visually, this X, to our proportion. In other words, we make an X. You see the X? You see the X in cross multiply? Okay. 2 times 10 is 20. Big whoop. So what? When you make the second cross, look at the magic. What also do we get? It turns out this happens every single time that you have a proportion. It will always happen. Right? I'll explain at the end of class why it always happens. Check it out. Proportion. This isn't cross reduction just because it's not multiplication. If there's a multiplication symbol here instead of an equal sign, we cross reduce. Instead, equal sign, we do cross multiplication. What's 3 times 16?
48.
What's 4 times 12?
48.
Works this way every single time. By the way, it must work this way. There are no exceptions. None. It will always work this way, cross multiplication. But I'll show you that. It's the very next thing we do. Okay? So our question is, well, so what? What do we use it for? Right? So let's write it down first. These are called cross products. This is just a fancy word for cross multiplication. Right? I never wrote down what was in box 1. Cross products. It says the cross products of a proportion are equal. In other words, if I take what's on the upper left and multiply it by the lower right, I will always get a same number as when I take the bottom left and multiply it by the upper right. 1 times 6 is the same as 2 times 3. This will always work, but do not confuse this with cross reduction. Cross reduction is when you have 2 fractions that are being multiplied together. Cross products. You see the X? When I say cross multiply, multiply is that symbol. It's the same symbol. Cross products. Questions? So what, which is what Abby asked, is this. Okay, everybody stop what you're doing and look at the board. This is what homework will look like. Is that a proportion, yes or no?
Yes.
Well, how do you know?
Because it has
Well, the cross products are equal. What's 2 times 10?
20.
What's 4 times 5? That's how I know it's a proportion. Cross products are equal. Tonight for homework, instead of giving you a proportion, they are going to take one number. Doesn't matter which one it is, and guess what they're going to do?
They're going to make it into a letter.
They're going to erase it and replace it with a letter. So it's going to look like that. Guess what your goal is to do?
Find the missing number.
Find the missing number. So we are going to use cross multiplication to do this. So to solve for the missing number, here's what you do. We cross multiply. To cross multiply, we multiply 2 times 10. What's 2 times 10?
20.
Okay. What's 5 times x?
20.
What? Well, yes, that is true, but we don't know that yet. So what's 5 times x?
Right now it's
5x.
5x. Okay. We know that 2 times 10 is 20. We know that 5 times x is 5x. We just put those 2 answers together with an equal sign and solve. Okay. Hey, what's attached to x? What number? How is 5 attached to x? How do we get rid of multiplication? So what are we going to divide both sides by? We divide both sides by 5. What is 5 divided by 5?
1.
Cancels. What's 20 divided by 5? Right? I always say the answer. Why is 20 divided by 5? Therefore, the answer is x equals 4. Do you see what I did? Let's do another one. Because we need practice. To solve for an unknown in a proportion, you do cross multiplication. Okay? It doesn't matter which one you do first, by the way. You can do 2 times x or 7 times 10. 7 times 10 is? Okay. 2 times x is? Okay. So we get that 2x or 70 is equal to 2x. We solve. What's attached to x? How do we get rid of it? How do we get rid of 2?
Divide by 2.
Divide both sides by 2. What's 2 divided by 2?
1.
The ones cancel. What's 70 divided by 2?
45.
Nope. What's half of 70? 35. So x equals 35. Why am I putting a 1x there? To show you that when canceling doesn't mean it turns to 0. It turns to a 1. But 1 times x is x. Yes. I will show you. There is no easier way. However, there is a shortcut. Right? There's no easier way. This is what you do. But we'll talk about it. Let's set up right now in Algebra 1, my kids are doing this right now, literally. And there's no shortcut step in Algebra 1. Okay? The only difference is their proportions say something like x plus 7 and 2x minus 4. And this will say 7x, and this will say 10 plus x. That's what they solve. They have to cross multiply. So if I say, hey, use this shortcut, we don't learn this, you get to Algebra 1, you can't solve the harder proportions. Right? All right. So here we go. And by the way, what we're really saying here when x equals 35 is what makes that proportion true. 7 times 10 is the same as 2 times 35. All right, let's do one. Here we go. Box 3. Cross products in a proportion are equal. So we do the cross products. What's 3 times n? What's 2 times 9?
18.
So we get 3n equals 18. We get 3n equals 18. 3n, I'm showing you this. I will stop showing this here in a second. You can immediately write 3n equals 18. You must write 3n equals 18 and solve. What's attached to n? How do you get rid of it? It's the same thing each and every time. We divide by 3. 18 divided by 3 is 6. The 3's cancel, and we're left with n equals 8. 18, n equals 6. Yes?
Because they're the same, could you just find the one for the second one? Like,
What do you mean?
9 times 2, and then you get 18, and then just find the number without having to do the.
You gotta give me an example.
Well, like for like the one that we had before the slide.
Well, how about this one?
Well, what you could do is you could just have the 9 times 2 equals 18.
9 times 3 equals 18.
9 times 2 equals.
Okay,
18.
I did. I wrote that.
And then you could just divide by the 3.
Well, isn't that what I did?
Well, I was just saying that you wouldn't have to do the whole like.
Didn't I divide 18 by 3?
Yeah, but you wouldn't have to do the whole 3.
This is her point, that she's trying to make this a shortcut. And I want to point out to you that you must do cross products, exactly what I showed you, because as soon as I write 2 plus x, now what are you going to do? You're going to multiply 9 times this times this, and you're going to solve, right? So you have to learn that it's the cross products. All right. Box 4, here we go. Someone still hasn't made typically someone else makes another smart comment at this point, but no one's made it yet. All right, maybe you were about to. You were? Okay, I'll let you make it here in a second. Here we go. 3 times 20.
60.
5 times n.
5.
So I get 5n is equal to 60, you said?
Yeah.
So write that down. I'm showing you this just to show you what the cross products equal. But what you really need to do is simply write 5n is equal to 60. You can do that in your head. That's fine. No issues with that. I'm showing you this part. Don't think you have to do this. It's showing you this part is where did you get 60 from? 3 times 20. Where did you get 5n from? 5 times n. How do we solve this?
We divide by 5.
Isn't that what you told me is the shortcut step? I just take 30 or 60 and divide by 5. I'm not saying I'm doing any extra work here. I just divide by 5. What's 60 divided by 5?
Well,
So n equals 12, and you're done. What?
There are also another.
Okay, hold on. Box 5. Here we go. It's a proportion. I know that because it's got an equal sign. Two fractions. Malachi, tell me what I'm supposed to do here. Tell me what it is. And did you say the word cross reduce? You've not been paying any attention. Cross multiply. I said the number one thing that 7th and 8th graders make a mistake with is cross reduction, which you just said, and cross multiply. Thank you for making my point. The names sound just alike. It's easy to make that mistake. Malachi, what's the difference between cross reduction and cross multiplication? Not true when you get to algebra 1. One involves, are you listening this time? Because I'm saying you're going to screw this up big time if you're not paying attention. One involves multiplication, and one involves, what am I pointing to? One involves an equality. The one for multiplication is the reduction. The one involves equality is the proportion. The proportion is what we use cross multiply with. Give me the cross multiplication. Just cross multiply. That's it. What is that? So I write 30, and then I write what is 6 times W? Don't overthink this. What's 6 times W? Where are you getting a 5 from? What is 6 times W? It's 6W. That's it. That's the answer. 6W. When I multiply 6 times a variable, I don't know what it is, so I just rewrite it. Hey, the only thing I did here was erase the dot. It's 6W. That's how you multiply a number with a variable. When you're like, well, what did you just do? I didn't do anything because I can't until you tell me what W is. So what's 6 times W? So 3 times 10 was? 3 times 10 was? So I write 30. That's your first cross product. What's the second cross product? What? 6 times W is not 6 equals W. 6 times W is? What is 6 times W? But what do I need to write? What is X plus 1? How do you know that? What if X is 10? It's 11. What's X plus W? What is X plus W? X plus W. X plus 1 equal? Do you know? Yes or no? So when you don't know, guess what you write? You just rewrite it. So what's X plus 1? Did you rewrite what I just wrote? So what's X plus 1? When you don't know, you rewrite it. What's X plus 1? Boom. What's 6 times W? Boom. That's it. In algebra, when you don't know, all you can do is rewrite. That's it. What was 3 times 10? I wrote it. Equals, what's 6 times W? I don't know, so you write, but how do you physically write 6 times W? Okay, and here's the only kicker is that we are lazy, we don't put the dots. We just write 6W. There's no dot, there is a dot there, we just choose not to write it. That's it, that's the answer. Now we solve that equation. 3 times 10 is 30. And by the way, just to point out, when you don't pay attention, guess what happens? We spend 5 minutes to catch you up to where the rest of the class was at. Please pay attention. Or if you were paying attention, how come you didn't say, I don't know what I'm doing? You know what I mean? All right. So that gave me 30. That gave me 6W. That means 30 equals 6W, and we solved that. Malachi, how do you solve this equation now? Where's the variable? What side is it on? What's attached to it? How's it attached to the inverse? I didn't solve anything. Where is the variable? Left or right side? Okay, what's attached to it? W is the variable. Okay, how is 6 attached to W? How do we get rid of multiplication? How do we, well, what are we going to divide both sides by? So let's divide both sides by 6. What's 6 divided by 6? What's 30 divided by 6? So what's the answer? Okay, and 1 times W is W. So W equals 5. Let me see, I knew that a long time ago. Because you said what times 6 is 30. That's the algebra. Okay, you need to do another one again. All right, the rest of you do box number 6. Malachi's going to do both of these. Here we go, Malachi. Tell me what to do. No, you're going to talk it out. You just tell me what to do and I'll write the answer. Do what? Divide?
Reduce.
There's no reduction. There's no cross reduction. There is no multiplication. There's an equality. When you see an equality, you cross multiply. If this said 1/2 and over here it said 10 over 21, right, with a dot in between, now we do cross reduction. Oh, that turns into 1. That turns, that's cross reduction. Why? Because it's multiplication. When you see an equal sign, you immediately do cross products. Cross multiply. Cross multiply. Just cross multiply. Cross multiply. Some people call this the butterfly method. I don't see a butterfly. I see next. Tell me what to multiply. I'll do it for you. 3 times 12 is 36. Now what? That's 9x. So I write 36 is equal to 9x, and I solve that. How do I solve that, Malachi? Both sides by. Now you're cooking. 36 divided by 9 is, so x equals 4. Boom. Keep going. That's not a 13. That's 48. That's 8n. Answer? Okay, you got this or not? Okay. Hey, are there any other Malachis hidden out there?
Oh yeah.
I found one. A Malachi would be, well, at least in this particular case, would be someone who sat there, they're not paying any attention, and all of a sudden the teacher calls on them, and they are completely, totally lost. And we spent, what, 8 minutes? And now Malachi is the best in the class,
Nope.
right? Yes or no?
No.
Okay. You literally already did your, how did you do your homework? Well, tell me how you did it. Okay. Well, you couldn't talk about it. All right. Now I get to call on my 2 smarty pants here. Tell me the easy way.
Okay.
I'm being sarcastic. You can't tell.
This one here tell you.
Tell me the easy way.
So you see that the 2 denominators, numerators, sorry. So 3 went to 9, so you know that you did 3 times 3. So you know at the bottom you did something times 3, so you did 4.
Okay, you see what he said? He didn't say it very eloquently, but he said it. I understood what he meant. He said, hey, look, somehow 3 turned into a 9. And well, how does a 3 turn into 9? He said, well, clearly I'm multiplying by 3. So basically I need to take the bottom and multiply something times 3 to get 12. And that something would be
4.
Well, that's stupid. Why is the math teacher showing me the hard way of doing something? I was expecting Malachi to give me that. Like, you're doing it the hard way. There's a much easier way. Okay, smarty pants. Do it.
But this time.
Oh, but. Okay. Notice, I can't tell you what multiplied by 2 is 3. Right? So
1.5.
sometimes there can't be a nice, easy answer. Okay. What's the answer? Oh.
Oh, well, you can start from the other side.
You can. What times 7 is 16? You see what I
2
mean?
point something. I don't know.
Agreed, right?
2.2.
The point being is that, yes, there is an easier way for some. For most of them, there's not. I shouldn't say it. In 7th grade, it's all, most of them are easy. But I do want to point out, I don't know what, well, I do know what 2 times 3 is easily. However, cross multiplication works every single time and it's easy. Malachi, show me your big brain. Cross multiplication. Oh, look at him going now. Okay? Let me catch up with you. 10. And you get? Oh, I know Malachi knows this now. No doubt in my mind he knows what he's doing. Okay, the point being is that when the numbers aren't friendly, well, then you got to use this technique. So for me, I'm all about, let's have fewer rules, right? Let's just stick with one rule. Now, I'm not saying for those of you that are on the ball, you're like, wait a minute, I hear what you're saying, but it was one of the easy ones. I would still do it the easy way. That's fine. But I'm going to point out, what times 5 is 6? I don't know. What times 5 is 6, Ace?
Oh, there is an easy way.
What times 5 is 6?
1.25.
Right. Well, if you can figure this out that quickly, is that true?
5 times 6. Yeah. Because
Grab your calculator. Do 5 times 1.25. Tell me you get 6. You don't.
you get 6.25.
So you don't get 6, so it's not
It's
1.25. Right? The point being is that you're going to get numbers that you can't use that technique. So how about we just do cross multiplication? Oh, tell me how.
So you see the denominator, see it's 10.
Yeah.
Numerator.
No, he said denominator, right?
The numerator is 5. So 10 divided by 2 is 5. So you know.
Oh, okay. All right. So he's using a third technique now. Instead of using multiplication, now he's using division. He's saying, oh, 5 or 10 divided by 5 is 2, so I just need to do whatever here divided by 6 is 2, and that would be. So now he's got a third rule. You down with what I'm saying? Right? There is easier ways of doing some things, but now we're having rule upon rule upon rule. Nothing wrong with what he said. Absolutely 100% good for you for figuring that out. I'm all about, for most students, like, let's stick to one rule, cross multiply. By the way, when we get to Algebra 1, do I have the Algebra 1 test handy? I do. I mean, this is what you're going to be doing next year, or next 2 years. You can't look at the two numbers and figure, oh, X must be 4 from that. However, you can rely on cross multiplication.
I want to see the big ant. I want to see one of the.
You don't, it'll give you a headache. All right, so cross multiplication is the one tried and true technique that all you got to remember to solve problems like this. So let's do this one, cross multiply. All right? 6 times 10 is, 5 times x is, so I get 5x is equal to 60, or 60 equals 5x, however you want to write it. Once again, I'm just showing you what the cross products are up here. 5x equals 60, and solve that.
12.
Divide both sides by 5, and you get 12. And you're done. Question? Sure. All right, any questions? Yes.
13 and 14, you can't rely on anything. So 13. 3 times 5 equals 15.
Give me the proportion.
All right, the proportion is 5 over r equals
5
2
over
3.
r equals
2 over 3.
See
So
what I
if you
mean?
go 3 times 5, that's.
So let's see. Your technique. Well, one of them was dividing what? Oh, that one's hard. Multiplying. Oh, that one's hard. Now I will say that the numbers still are fairly friendly, right? There is a way. I mean, some people can figure out, what times 2 is 3 or what times 2 is. They can do that. But you're dealing with decimals, and why don't you just use cross multiplication? 3 times 5.
15, but.
15 is equal to 2r. So what am I going to do to both sides? What's 15 divided by 2?
7.5.
and you're done.
We can put decimals on things.
Sure.
Oh, that opens up.
I'm just saying, nothing what any of you smart kids said, that's fine, but, and you get one of these, and then you're back to cross
I didn't
multiplying.
know we could put decimals.
So I will always refer back to cross multiplication as being the tried true trusty method. If cross multiplying was a long, arduous process, like it involved 20 steps, and his way involved 2 steps, I'd be all for his method. The issue is that he came up with 2 rules, and then there's still, for someone, we still have to cross. So he's got 3 rules to solve this. I'm all about 1 rule. Okay, don't change. Go ahead and do what you want to do. That's fine. Do what? Sure. All right, any questions on anything we did today? There is your homework.
Wait, is it 1, 2? Yeah.
Hey, we're out of time for late work in class for you guys. E-learners, as long as you turn it in to me, I need your homework. You guys, like some of you have some missing assignments. We're kind of out of time to get any late work turned in. Many of you have at least 1. Some of you have more than 1 missing assignments. Hey, today's Thursday. You give it to me by tomorrow, I'll accept it. Any late work after tomorrow, I won't accept. No, I'll just lose. Never turn in something early. I'll just lose it. All right. Questions on anything we did today? E-learners, if there's anyone online right now, any questions from you guys? There is one person. Who is it? Jameson. Jameson. Any questions?
Nope.
All right. Do you have donuts for us, Jameson? Today.
No. Sadly
No.
not. We're out.
Make us cupcakes. We'd all appreciate it.
I can make you cupcakes.
All right. I'm just joking, Jameson. Have a good day.
You too.
All right. See ya.
See ya.